This panel's on, come on up, folks. This panel's on sustainability by design, basically how to integrate sustainability in from the get-go. And it's going to be moderated by Melanie Loftus, who's a consultant on sustainable materials, broad background in green materials and green design. So, take it away.
All right. Thank you. Thank you, everyone, for bearing with us late in the afternoon here. I'm really excited to introduce our panel today on sustainability by design. So, the design process provides a key window where we can embed sustainability into our buildings, our products, and our infrastructure. And what we believe, I think, in this room, and sort of what we're assuming here, is that products and systems that are designed with sustainability in mind are increasingly resilient, adaptable, and they have attention to the appropriate human scale use of technology. So, in our panel, we want to talk about where we're seeing the successful integration of sustainability into design, as well as what tools and frameworks support an approach to life cycle design and systems thinking. So to introduce our panelists today, Linnell Cameron is president and CEO of the newly formed Autodesk Foundation. She's also the senior director of sustainability at Autodesk. And Larry Strain is a principal at Siegel Strain Architects. Jonah Houston is a senior project leader at IDEO. And Beth Ratner is the executive director of the Biomimicry Institute. So I wanted to start out with a question about where we are today. And this group has a wide array of experience in different industries and at different scales. So I actually wanted to start with Beth with the question about what is broken in our current way of designing, and where do you see the biggest opportunities for improvements in the way we design our places and our stuff?
Sure. So before I was at Biomimicry Institute, I was with the Cradle to Cradle Products Innovation Institute. And before that, I was a management consultant, and before that, I was with Linnell at HP. So writing
the first sustainability report.
Writing the first sustainability reports there were on rocks where we chiseled them out. It was so a lot of what I do in the nonprofit world is really informed by the for-profit world. I'm also a lawyer, so I can't get away from that. I thought a lot about this question about what's been broken because for years we get asked that question, which is, what's the one thing I should do? What's the one thing I should focus on? And I think it kind of there's a philosophical answer here, which is there is no more resources than what we know about. There is only one planet. These are really fundamental concepts that for whatever reason aren't even being talked about today. This is the blue planet picture that was taken in 1972 from NASA, right? This is it. And the way that we make our shirts, we're emitting about 7. So this is a long answer, but I think it's a story, which is the way you make your shirt. It's got about 750 metric tons of pigment and dye that we're releasing into our water systems every year. I had lunch with someone from the TNC, and I said, "Hey, I'm going to mention diatoms because the pigment that we're releasing into our water systems is effectively killing off the phytoplankton, which is responsible for about 1/2 of the air that we breathe." Where's my TNC person? I think my numbers are right. But so if we can't figure out how to make a shirt that's not going to deprive our oxygen levels, we're not doing something right. So this is the core of what's broken, which is we've lost that perspective that we're all connected.
Mm-hmm. Great. And actually, Jonah, I wanted to get your thoughts, too, because I know you've worked on an infrastructure level. Maybe give us a sense of, from an infrastructure perspective, what you're seeing is broken in our design system.
I mean, at the risk of being sort of too IDEO about the answer, I think the thing that there could always be more of is sort of more empathy for more users of the systems, right? I think we tend to design for ourselves. I think we tend to think, even when we're doing infrastructure level projects, I think we tend to imagine them for ourselves and don't consider all stakeholders, don't consider spillover effects, don't consider enough of sort of unintended consequences, and so there tends to be going back to the previous panel, it tends to be sort of KPIs and things, incentives that are put in place that we design towards, and that drives a certain type of behavior and a certain type of design process that you think about the new eastern span of the Bay Bridge, right? We sort of took 25 years to figure out that the bolts were broken because for a variety of reasons, but it's an example of kind of not thinking systemically and thinking in a kind of narrow way, and so our mandate in the world is to be very broad and make sure that we are considering as many stakeholders as is feasible and bringing that perspective, not that you can sort of satisfy all needs at all, all the time, but that you are at least paying attention to them. And I think that's a thing that tends to, for a variety of reasons, I think a lot of them financial, frankly, just doesn't work with the present way that we think about sort of systemic projects.
Mm-hmm. And I think that question is obviously very broad, so I appreciate you guys bearing with me and giving me very helpful, specific answers. But that also brings this concept of we have a lot of stakeholders. Most design is done implicitly or explicitly with a client or a customer in mind. And so sometimes those customers or clients come to design with a conception of what design is or what design looks like. And that can be a challenge because it doesn't always fit with the way that design has evolved. So Larry, I was wondering if maybe you could talk about how do you address those underlying beliefs of a client or a customer, or I guess in your case you'd be working with clients, and then how do you try and bring those beliefs to light, confront them in a way that's meaningful and helps you allow the client to see new opportunities?
Yeah, I guess when we're going to a new client, a lot of clients come to us because they want green design, so we're lucky in that sense. We're sort of pre-selected. But we try and figure out what their core beliefs are first, and then you can almost always work sustainability to fit their core beliefs. It's kind of like mom and apple pie. It's like nobody's really against it. If you ask them flat out, are you against sustainability? It just doesn't. That's not the way it works. So, but there are people that are concerned about one thing or another, and so you try and figure out how do you tie the sustainability measures you're going to put in your building into what they really care about. So about 8 years ago, we did a town center for Portola Valley, and what they really cared about was open space and the natural environment. And so when you first try and sell someone the idea of conserving things, they'll go along with that. But if you say you want to spend more money on FSC wood or used lumber in your project because you're conserving what you care about, even if it's not your piece of land, you're conserving a forest in Northern California by doing this, it doesn't take long to get them on board. So you try and tie your ideas, where you think you have the most impact, and tie it into what they really care about. And usually it's pretty successful.
Okay. And Linnell, did you have any thoughts on this? You're obviously designing products in a way for end customers, and how are you looking at sustainability issues in a way that you can help customers tackle these issues?
So I lead our work at sustainability, and we have a really interesting and unique vantage point, because what we're trying to do is what we've all sort of been talking about right now, is simplify the complexity that's out there, right? So, when you boil down sustainability, it is really about fifth grade science. Somebody mentioned that on one of the panels. It's as simple as the water cycle. There's a finite planet. It's basic. We all learned this a long time ago. But the reality is, as we've heard all day today, is it's also inherently complex. And it is the systems challenge. And you can't talk about energy without talking about water and materials and this interplay. And so I think what's broken, to your first question, is it's so complex, and we haven't done a good job as sort of broad sustainability professionals, if you will, in really simplifying it so that people can understand the trade-offs and get a foothold to actually make progress on some of these issues. And so that's fundamentally what we spend our time doing as a sustainability team. We take our own footprint, have our own 100% renewable goal, but really it's about helping our customers, and this is hundreds of millions of customers, understand in the design process which is a better decision? Which material? How do I make energy decisions early in the design process when it doesn't cost money, right? So you can change the orientation or the shape of a building long before you get to the windows and the glazing and the things that add cost. And so I think when we're talking about scale, it's about simplifying and democratizing each of these decisions, whether it's at supply chain or the design table or whatnot, so that we can quickly make progress on the most important levers, if you will.
Great. So you started mentioning materials, and materials I think is a very important subject that we'd like to talk about now. So Jonah, maybe you could start to talk about, based on your experience, what does the role of materials play in sustainable design, and how can they improve or negatively affect the outcome of a product?
You know, so we were having this conversation last night at dinner, and one of the things that I'm really struck by is how kind of the basics of material science is essentially table stakes at this stage in the game. 10 years ago, 12 years ago, when we started bringing that to the conversation, I mean, I think the simplest way is, we had this heuristic where we would never paint plastics. Like, we would never design something that had painted plastic. Start with a plastic that's the color that you want the final design to be, and that saves a bunch of, a bunch of stuff. But at this point, that's it. Like, everyone that we encounter sort of has ingrained those kind of really simple heuristics as part of the design process. And what I find to be super interesting is that we're now getting pushed, right? As a result, in a lot of ways, as a result of these standards, and that there's a general awareness, so that the bar is set reasonably high. And for us, the questions are less around the specific, or the questions that we're getting asked by our clients are less around the specific sort of impact of, if I choose, the PCABS over an RPET or something, these kind of very tactical kind of what's the energy burden of this or versus that. But still thinking quite a bit around desirability and around how do we tell the story of what this is, and I think if you look to firms like Patagonia, where they're sort of actively telling people not to buy their stuff, right, or buy fewer things and keep them for longer, I think those are the stories that are really starting to push on the edge of how materials sort of science has an impact in how you think about product design. Mm-hmm. Because we do have finite resources, and again, I think Yvonne Chouinard is quite vocal in saying, like, look, it's just sort of levels of badness. If you make something, you're having an impact, right? Mm-hmm. So the emphasis has gone a little bit away, at least from the world as we see it at IDEO. The emphasis has gone a little bit away of, like, well, how do I balance sort of one polymer versus another, and more towards, like, what's the sort of general use case?
Mm-hmm. Yeah, and Beth, I was wondering if you could talk about how biomimicry looks at product design, and also because you were a co-founder of the Cradle to Cradle Products Innovation Institute, if you could talk to a little bit about how you looked at product design in that framework.
Jonah, it's such a good point, and Linnell's right, because you have to simplify this. But to some degree, we have this amazing model. There's Kim, so she knows the answer to this. So I'm going to say we have this amazing model in front of us, which is nature, and nature's been doing this for billions of years. Quite literally, the same exact functions that we're trying to accomplish today. It does adhesion, it does filtration, it creates pigment, and we forget that. For whatever reason, we look at a butterfly, we're like, that's a beautiful butterfly, but it's actually a very complicated design. And the sooner we realize that we can actually emulate that design, and not just with bad materials. Let me give you an example. MIT right now, or just a few months ago, this is in Nature magazine, which kind of kills me. So in Nature magazine, MIT talks about the most water-repellent surface created to date, and it's modeled after a butterfly wings and a nasturtium plant. And we're like, this is going to be a great biomimicry story. And then you read down, and it turns out the materials that they used to do it were C8 fluorinated hydrocarbons, which are pretty much the nastiest stuff that you can't even buy in the United States. Like, you have to import it. And if a real butterfly flew into the lab, it would die instantly, right? That's how nasty this stuff is. And so Nature magazine is like, yay, butterfly. We're like, bad. Because if you cannot get away from the fact that we're still so nascent about what we use for material design. And I think that the goal to get to is not just that, we're trying to do a little less bad every time we make a shirt or we make something. It's to be a net positive. Can we filter our water while we have factories? And the answer, I think, is going to become yes, hopefully in our lifetime. It kind of has to. To be honest, it has to be. We sort of can't keep hoping for it.
And there's been a lot of discussion in the built environment. In Northern California, there is the Building Health Initiative, which I know Facebook is a part of. And so, Larry, I wanted to see if you could talk a little bit about, we're building these increasingly tight buildings. Over time, we've seen that this has had an effect as well on the health of occupants in these buildings. And in addition to looking at the health of the materials in the building, it's starting to shift the focus of the embodied carbon of the building. So could you talk a little bit about this evolution of how the building industry has changed with time and how our analysis of materials is changing?
Yeah, I guess I'll start by talking about the energy and the embodied carbon piece and the carbon emissions. It seems like there's a big push for net zero buildings. Like that's the new gold standard for what we want to do is build net zero buildings. I think that what we have to start looking at is the total carbon footprint of a building. And a lot of that's in making the building, and a lot of that's in operating the building. And it used to be that the sort of rule of thumb was, well, over a lifetime of a building, only 20% is going to be the embodied carbon. The rest is all operating carbon. So don't worry about the embodied carbon. Just make it really efficient. Well, as buildings got more and more efficient, that started to shift up. The percentage gets bigger and bigger as the building gets more efficient. When you get to net zero building, it's all the carbon you're spending is building it. The other piece to this is that there's a time scale to carbon emissions. It's not like we have 80 years to solve this problem. We've got 20 years to do something serious about climate change. So what you're looking for is the biggest bang for your buck in the shortest time period. And right now, that's the materials, not the operational carbon in a new building. If you build a new building, in the next 20 years, more than half of the carbon responsible from that building will be building it, not operating it. So you've got to start addressing the embodied carbon impacts of a building. And you can do that partly with the materials you select. You can select lower carbon materials. You can select wood over concrete, maybe for a structural system. You can maybe avoid vast aluminum curtain walls, things like that. But that's still not going to solve the problem. The other problem is that we build about 6 billion square feet a year, and we have 300 billion square feet already built. So even if we built all those 6 billion square feet a year net zero, what about the 300 billion square feet we already have? We have to start taking all that 300 billion square feet and converting them into net zero buildings. And it takes carbon to do that, but it takes about a quarter to a third the carbon that it does to build a new building. And then immediately it becomes net zero and takes it out of that picture. So I think we have to start thinking about carbon impacts in a much broader scale than just operational carbon.
So how do you do that?
Yeah, and so the first thing is reuse what you got. I mean, we're not going to actually build our way out of this problem. We're actually going to build, when you build more, like you were just saying, everything you do has impacts. When you create something, you create an impact. So we've got an awful lot of building materials locked up in buildings already out there. And if you remodel an existing building to net zero, you do two things. One, you didn't spend as much building as, one is all those buildings become net zero that you remodel. And the second thing is you're spending less energy than if you would if you were making a new building. So we've got to start building less and remodeling more and remodeling to net zero standards. And that's really, I mean, I don't see how we do it without taking existing buildings, really making it part of the conversation. I don't think we can do it with all new materials.
Okay, great. And then circling back to this question of health and materials, Linnell, you're on the board of the Center for Environmental Health. So I was wondering if maybe you could talk about health and materials and some of the work that the Center for Environmental Health is doing. And then, Larry, you've been involved in healthy materials and construction. So could you both talk a little bit about some of the work you're doing there?
Yeah. So I think with materials, there's a lot that's already known, right? We know, and some of them are tactical decisions, but we know a lot about what's really highly toxic and what And we know less about what's a good alternative, I would say, and lots of research that needs to be happening there. And so at Center for Environmental Health, we are basically testing thousands of products that are already on the market that have very, very harmful chemicals in their markets that they're not supposed to be there. And so that's the work that we do to really change what's in our products. And one of my colleagues on the board asked the question about the toxic shell game, and that's exactly what it is. It's a toxic shell game. So I think what that begs is some work that Beth and I are starting to work on together, which is incentivizing the research community to come up with new and better materials. So my company, Autodesk, which has traditionally been design software, helping people design better things, we sell 3D printers now, right? And we are very much in the 3D printer market, and there's a lot of innovation that needs to happen there from a materials perspective, especially when you think of the scale that 3D printing is going to take. So I think there's a need for us in the corporate sector to incentivize the right kinds of research and innovation in the halls of UC Berkeley and Stanford and all these other institutions. And then there's also a role for us, certainly as a design software company, to help democratize better decision-making around materials. So just briefly, and Larry thrilled me yesterday by talking about how he's been using one of our tools that one of my colleagues here has been working on. But what we're trying to do is, whether you're designing a product or you're designing a building, or you're looking at a big infrastructure project, in the design environment, have a relatively easy access to decisions to make those material choices, right? So on the product side, we worked with an organization called Granta Materials, which is a huge material database in the UK, fantastic partner, to simply put a red, yellow, green meter in the design environment about which materials are better than others. It's really basic, but that's the point. I think the product that Larry's been working with is about understanding an LCA, and this audience probably knows what an LCA is, but a full life cycle analysis of materials upfront in the design process. Again, so that you can, because I think that the decisions that we've made over the last many decades from a design perspective were our best guesses at what was going to be a good place to live. And what we're realizing is, all of those bad decisions are unintended consequences of our best design intention. And so basically being able to now understand what Larry knows, but there's very few Larrys out there who understand those points. And so trying to build that into the tool set in a much different way than we've had access to previously. So it's exciting. I mean, I think as a result, hopefully the process of design itself is changing because we do have access to this kind of information.
Great. And Larry, do you want to talk about some of the work that you've done?
Well, there's sort of two pieces to that. I'll get to the Tally tool in a minute, which is this great tool we're using on a project. But the other piece is we got into some of the toxic issues, and I will say that we've been working on sort of healthier materials for a long time in our projects, and we sort of design small buildings that are mostly wood and pretty simple, and they don't have a lot of toxic materials in them. We don't have a lot of corporate offices that are full of vinyl wallpaper and things like that. Not that this is, but check. But I would say that the one thing that's happened that we saw kind of coming is the California Energy Code changed last year, and it got much more rigorous, and what it started to require was exterior insulation on the outside of buildings to make them, to eliminate thermal bridging and make the buildings more efficient, which is all great. Most of what's used for those exterior packages is foam. Foam insulation has halogenated flame retardants that are some of the most toxic and most persistent chemicals in the world. They go everywhere, and they just stay in the world. They migrate up the food chain, and they end up in the Antarctic, and they don't go away. So it's, so you have to start thinking about, well, how do you get those high energy standards without the foam? And so you can either work with other materials that aren't foam, which typically aren't as high in R value, so that the assembly changes, the whole way you build a wall changes, or you start pushing the foam industry, which we've been working on trying to get them to change the code so they don't require these halogenated flame retardants in their foam, which turn out don't work anyway. That's another story. So, and someone finally did it. They now have one foam is out there without the halogenated flame retardants, and it's taken 5 years of pushing on them. So part of it's getting companies to get on board, and part of it, that's going to come from pushing. It's not going to come, it's a cheap way to build, and they know how to do it, and they're going to keep doing it until they're told they can't do it anymore. So I think that's part of the story with that. With this other tool that Linnell mentioned, we're doing a study of an existing office building, DPR office, Ted's here. It was an existing building that was a net zero. They made it into a net zero office building, which was great. We decided to use the tally tool to look at the total carbon impacts of that project. All of the carbon they put into making it and the carbon they're saving. And it was just this amazing. So this wasn't done as a design tool because the building was already built, but it was a way to go back and verify how much carbon they saved by reusing that building. And when you have a Revit model, it's got all your materials already in your model. The tally tool just as a plug-in that basically tells you what the environmental impacts, the life cycle assessment of each of those materials are. So it's an amazingly powerful tool for designers to use during the process or even after to go back and see how you did. So.
Can I build on something that
Yep.
Larry just said for a second? So one of the big ahas that recently was exposed to me by Berkeley Center for Green Chemistry guy that we're working with, he said, okay, so the reason why those halogenated fluorocarbons are so persistent and the reason why things are so toxic is because they come from petroleum, they come from coal, which were the things, if you think about it, these were the things that didn't biodegrade. And I'm like, oh my God, why did that never occur to me before? We build everything in our society from a chemical base set of the stuff that didn't degrade in the ground. And we're surprised now that it's like in our bodies and it's in polar bears. We're like, where did this come from? Oh yeah. So it's a super fundamental realization. And if you go back to the 1820s, we grew twice as many plants for industry as we did mining. So we were on a carbohydrate economy versus a mineral economy back then. We used it for energy. We used it for our pigments and our dyes. We grew everything. And we didn't do it super well. We deforested in the process, et cetera. But with carbon farming now, this whole idea that we can actually be sequestering carbon out of the air through really great composting. If you guys don't know what carbon farming is, you have to look it up. Carbon farming. It might actually save us. I don't ever make those kind of comments, but holy smokes. If you can actually rebuild your soil and it sucks carbon back out of and you're growing now crops that are net productive. So imagine now if we had the green chemistry know-how applied to cellulose and lignin and chitin, right? All of these fundamental elements of nature that we stopped thinking about iterating back in 1820.
Wow.
I wanted to talk a little bit about tools. So specifically we've had some mentions of some software programs, biomimicry as a framework. What are some of the tools that you're using? Jonah, I know that IDEO is known for developing tools that aren't necessarily just sustainability related, but allow you to engage in a sustainable process. So could you talk about some of the tools you're using specifically?
I mean, so kind of famously, a few years ago, we did a project with the Gates Foundation to do a human-centered design toolkit for the developing world. That was going back to sort of point one, which was how do you involve stakeholders and kind of take a human-centered design perspective against projects. This one in particular was in the developing world, as if there were sort of dramatic differences for humans in the developing world and the developed world. But anyway, that was the project, and we did it. And so we put together a kind of a step by step for how you approach, how do you sort of go and get user research? How do you integrate that sort of carefully into design process, or what are sort of basic frameworks for synthesis? How do you conduct brainstorms? How do you sort of iterate and bring in new ideas and then filter them in an effective way? And then we built this whole thing and we put it on the internet, and it's available for anyone to download for free. It's also we did a subsequent one for educators.
And what is it called?
It's the Human-Centered Design Toolkit.
Human-Centered Design Toolkit. Okay.
Again, one for the developing world, one for educators. So those are tools. It's slightly. It's not quite orthogonal to the conversation we're having here today, but the design process that IDEO goes through that I think is, the D School is obviously, taking and doing versions of it for all of the graduate programs there. All of that stuff is they're sort of toolkits per se, but I think they're more fundamentally, if you can really kind of become familiar with them, they become really effective heuristics for sort of how to think about how to make design decisions. And because it's not quite as rote as step by step. Oftentimes we get people saying like, oh, how is it that you guys give away your kind of special sauce? Because in some ways that's all that we really have, right, is our design process. But the practice of it is the thing that sort of makes you good at it or not good at it. And so becoming familiar with ways in which you can incorporate, sort of start from a place of empathy and incorporate multiple stakeholder views into the design process. As that becomes a heuristic, then there's versions of it that are relevant for, we've done the same thing for P&G, we've done the same thing for lots of, for Kaiser Permanente, for lots of commercial clients as well, but fundamentally it's about sort of always having that perspective, which is, how do you bring people into design considerations, and how do you sort of make those concerns persistent?
And Beth, I know that the biomimicry has a lot of tools and frameworks that influence a lot of designers. Could you talk about that a little bit, and then Linnell, some of the software programs that your company has?
Actually, Linnell was responsible for helping fund one of our most important tools, which is Ask Nature, which is actually built on React and Flux.
Not me personally.
So a little shout out to the Facebook team. But it's really important to have a repository where you can go to say, how does nature desalinate? Right? We're looking in California, we're looking at a huge crisis right now around how to desalinate water. The current methodology, pretty energy intensive, pretty destructive. Not a lot of forethought as to what's going to happen to the brine. There are actual mechanisms in nature that teach precisely how to do this. We think these kind of tools need to be available to all developers, to all designers, to lay people and the like. And so if you go to asknature.org, that's something that Autodesk was critically important in helping to fund. And also on challenge.biomimicry.org, we have a whole set of resources available for how to start this process of nature's blueprints exist by function, right? So you have to decide what function you want, and then you can decide what the structure is that you need to get there. And that whole methodology is actually outlined on our site as well.
Great. And Linnell, did you want to talk?
Well, I would just say, so there are lots of frameworks out there. Human-centered design is so renowned right now. Biomimicry, that's nature.org. If you're not familiar with it, definitely check it out. Certainly the LEED framework, the circular economy, the cradle to cradle, and all of these, I think, are helping to push the needle. And what we're trying to do is make the link between these frameworks and our customer base, which is architects, engineers, industrial designers, lots of people, and partner with organizations like Biomimicry to say, you guys have this incredible access of biological data, and none of our customers have any idea how to access it or use it. None of them are biologists, et cetera. So how do we build those links? And I think that's fundamentally what we need to do to bring sustainability to scale to the point of today. And I think another interesting tool that I want to mention, because it's relevant to some of the conversations earlier today, which is about triple bottom line valuation. And I think it was Peter who mentioned, we measure the economic metrics and financial metrics because we know how to, and it's easy, and we kind of ignore the rest. And so one of a new tool that we've put out there called AutoCase, which is looking at trying to measure the social, environmental, and economic value of a particular project. So you can either compare two different design options, or you can compare, an infrastructure stormwater project versus a transit project, and which one is going to yield the public benefit that you mentioned as well that we're actually looking for, whether it's more open space or it's all different factors that you want to talk about. And so again, it's like we do that in partnership with infrastructure impact, I think, partner. But the point is, how do we collaborate with across the kind of people that are here in this room, and certainly with a lot of our NGO partners that are here, to bring the best of what we know to the masses who are making design decisions every single day and have no idea that they have agency, really, to impact the trajectory that we're on, decision by decision. And I think that's the real opportunity that we can leverage technology for. And actually Facebook, when you think about the incredible network and everybody who's not in this room, but they work at Facebook, what if we tap into that whole community to help simplify and democratize sustainable design? So I don't know if that answered your question.
Yes, that was great. So now we're looking at these design processes, we're looking at these different tools and trying to bring them out. How do we start to define success, or how would you recommend that people start to look at the success, measure success in their design process? And Beth, I know that biomimicry talks about this. How do you know if your design process is predictable, if it's adaptable, if it's resilient, and if it's generating optimal outcomes? How can you start to get a feedback process going to know if you are, in fact, practicing sustainable design?
I actually bet that all of us would have the same answer, which is you walk in and you can breathe. That's a really good metric because honestly, right now you walk into most places and you're like, I cannot breathe. That is, or it's so, it smells bad. And your sense of smell is actually a huge indicator that there is something wrong. The sound that you're hearing right now, the fans, circulation, that's a huge indicator that that is not an efficient system. Our senses are actually very perceptive at knowing, because we are biological beings, we are natural beings, we actually, if you walk into a park, you walk into a forest, you're like, this feels right. You walk into a building, this feels wrong. And there's actually empirical ways to start measuring how much oxygen are you producing, how much clean water are you producing, what is your base material inputs that were used. But let's start with ourselves.
Mm-hmm. Larry, did you have any thoughts on this as well?
Well, I guess we get feedback from our internal team, from our consultant team, from our clients. And mostly we look at what didn't work in the last project and try not to do it again. So that's a really good, every project you're going to screw something up. And that's where you learn the quickest, because it's usually a hard lesson. So I would say our feedback loop about what's working is by looking at what didn't work is a really good indicator.
Mm-hmm. And Jonah, do you have a way of checking to make sure that to continually improve your process at IDEO?
Yeah, for sure. I think step number one is that we don't believe that our process is sacred. So we're happy to kind of continue to evolve and iterate kind of on a day-to-day basis, right? So the way that we think about how we're going to learn about the thing that we want to do next is not set in stone. So the way that we do our research and the way that we prototype and the way that we kind of get ideas out in front of people changes, moment to moment. And so I think in that way, it's we just don't feel like it's this sort of cherished thing that sits under a glass dome that you're not to mess with, right? It's not a recipe, right? It's a kind of a fur ball of sorts, and don't tweet that or whatever. I think the other thing though, like the thing that I think about, if you zoom up a layer or two and sort of not think about sort of project specific metrics, but just thinking about you think about this conference, for example, and the sort of levels of engagement, right? And sort of who's paying attention to the question around sustainability, which is to your point, we have to solve this problem, right? And yet the number of people who are involved in this conversation is kind of disarmingly small, right? And I think that to me speaks to, if we're being honest with ourselves, it speaks to a sort of failure of us being sort of sufficiently empathetic to the sort of concerns of most people on their sort of most day-to-day decisions, right? You wake up and you're going to buy a car or turn on your air conditioning or sort of do all the things that are sort of energy intensive, and are you cognizant of the fact that that has an impact beyond the edges of your life? And if you are, then I think we're doing a good job, right? And if you aren't, then then there's more work to do. And I mean, that's a sort of lofty and maybe ridiculous answer, but I think like that's sort of how I think about it. And I mean, that's how we do, you know, I mean, our thing is like impact through design, right? So if people's lives are changed, if their perceptions are changed, then we're doing well, and if they aren't, then we've failed.
Okay, great. I'm interested in also hearing from the audience. If you have questions for the panel, please feel free to step up. We'll be taking some questions soon. Oh, Kim, do you have a question? Hi.
Thanks for the great panel and great moderation. I'm Kim with SCS Global Services. And here's a zinger for you guys. So given our first talk, which was showing increases in temperature, the extreme climate events we've seen, there's a huge amount of climate science out there that's not currently being accounted for. Given the simplicity that we need to communicate information, what do you guys see as a framework for accounting and showing that updated climate science that we're seeing? Notably, carbon, how we are accounting for other pollutants besides carbon on a shorter time horizon, knowing that we need to act quickly. Knowing that methane, for example, is much more potent when it's looked at a shorter time horizon.
You want real-time data? Is that what you're saying? Yeah. Like basically, we want to know how many refrigerants are out there. I don't think I understand the question.
It's actionable, though, right? Is it? I mean, is the question about how to make that actionable and how to sort of get people engaged in the?
Yeah, because we talk about tools, we talk about communication. We've got environmental product declarations. We've got life cycle frameworks. They're not yet accounting for this updated, realistic climate science. How do we communicate that simply?
Climate Central is a good website. If you haven't checked it out, it is actually sort of it's conducted by a number of scientists to sort of do at least the impact side of that. But in terms of the manufacturing side of real-time data, that's a good question. I don't know the answer to that.
I don't know if the people that are making these decisions every day need to know the real-time data on that. Because it'll change. I mean, it's way up there, but
it's huge. It's huge. Yeah, it makes so we're energy analysts
yeah.
On Facebook quite a bit with
Yeah.
Oh, do we have a microphone?
A microphone for these guys. But I think, well, I'm gonna jump ahead and say like, I mean, I just don't feel like the data is relevant, right? And like humans are sort of at their core pretty bad at right, biologically we're wired to like respond to like saber-toothed tiger, run, right? And not like 10 years from now, the sea levels are going to rise. Like we're not, and so I think part of the challenge is to contextualize the information, this sort of slow-moving, sort of scary information into ways that are digestible, right? So that it will have an impact on your decision if you're going to buy a Suburban versus a Leaf, and maybe that's a bad comparison. But how do you contextualize that information in ways that's digestible and relevant to people on a day-to-day basis? Like that's a thing that I don't think is being done, right? Just sort of like standing around being like, oh no, you really should be afraid. And it's like, well, if I got up today and it's a little bit warmer, or now it's a little bit colder, like, should I be afraid? It doesn't resonate, right? I actually have a lot of empathy for the people who are like, I'm not sure I get this, right? Which is actually why the sort of climate deniers have gained a toehold, right? Because the time horizon is so outside of the spectrum that most people think and plan in. So I think it's about narrowing that somewhat.
But maybe one of the other questions you're getting at is, and Linnell talked about this too, is sort of simplifying. How do you prioritize? How do you get people to focus on the things that have the biggest impact? And I think that's something we all need to get better at doing, because there are lots and lots of environmental issues, and some of them are imperative that we solve, and some of them we've got time to solve. And so I'm really trying to focus on what are the things we can do right now. So every decision around climate change especially has to suddenly have a time scale to it. It's not just, is it good or bad? Is it good or bad in what time scale? And if it's good for the climate and it's sequestering or lowering your carbon emissions in the near term, that's what you want to do. So I don't want to super insulate a building that's going to pay off in 80 years and spend 30 tons of carbon to make that well insulated. It doesn't compute. So you have to start re-asking every question with a time scale attached to it. And I think that's part of...
Can we go back to their question for a second as
the
well?
gentleman's back there, I think.
No.
Okay.
That's a different.
Oh, there he is. Okay.
Yeah.
Okay, so I think where we were going with our question is that fundamentally, Aaron and I always talk about this, that the building design and construction industry in many ways is probably the worst and laziest in terms of providing a feedback loop, especially from the engineering side. And we're both on the engineering side, and we admit this. And we get a lot of data out there that is theoretical data on what performance is, or we get subjective answers of kind of a little bit of what we got from you today is, does this feel good? Is this right? Who knows? We could have screwed it up. And the golden rule that we always operate by is assume everything you ever did or learned was totally wrong, because you might go through a process to rediscover and learn something new. And the reason that we need the real-time data is that while we're trying to go through and vet what's happening, we want to evaluate, we want to analyze, we want to see this data in real time. We want to be able to identify and address issues where we see something that might not be operating correct, because for so many years maybe we made the wrong assumption. And that's why we immediately jumped into that, when there was a question of, do we need this real-time data? Absolutely. If we don't have it, we're going to continue to make the same mistakes we've made for the last 150 years. So that's where our...
Totally agree. So I think you need real-time data at the level that you're working, because you're rapidly iterating and changing and evolving your design. So I think I misunderstood the question in terms of, because I was saying, some people need pieces of data, they don't need all the data, and let's get the data to the right people who are making the decisions that affect the outcome, is where I was going with that.
Great. And I think this gentleman's been waiting.
Oh,
have a
great.
question?
Thank you. I'm Tim Frank with the Center for Sustainable Neighborhoods. One of the, I think, really exciting new developments in the green building world is the growing recognition of the importance of design, not just within the four corners of a building, but actually looking at how buildings relate to the street, buildings relate to the neighborhood, and to the region. Because you can build a net zero building, build it out in a place where you actually require your occupants to drive a lot, and it's actually not much of a solution. So figuring out actually how to look at design as it integrates across these different levels of scale is critically important. It's one of those, as you would say, the priorities that we really have to focus on if we want to succeed at sustainability. So I was wondering if you could reflect on that a little bit.
Yes.
I would agree.
Yes.
No, I think that scale thing is just like you have to look at whole systems, you have to look at whole scales too, and not just solve your little problem. Interesting thing about scale at a building, going back to a building level for a minute, is that building scale actually affects sustainability. And there's been some of the LCA studies that happened over the last 10 years. If you actually look at what it takes to build a building and then make the building bigger, it takes more energy per square foot to build the bigger building. And it takes more energy per square foot to operate the bigger building. So the idea that we can build big, we actually have to look at scale as part of the solution at a building level. But you're talking about a systems neighborhood level too. But I think that one of the things is looking at one of the huge hidden costs in green building is the infrastructure that supports it all. Underground, all the utilities. And when you start to look at systems that address sharing those efficiencies and things in the utility system, mining heat out of the sewer system, or whatever it is you can do at a neighborhood scale, that's when things get interesting.
Well, you raised a really interesting point, which is that when you're actually considering, for instance, the energy impact of a building and its size and its scale, you actually have to consider the infrastructure with which it's relating. So, for instance, if you look at the San Francisco Bay Area metropolitan area and the transit system that serves it, and you look at the number of actually heavy rail transit connections, there's only a tiny number of stations, and the amount of area around those is actually quite small. And so for parcels that are located within a walking distance of that, you might actually have a different calculation from a parcel that's located out in a suburban setting that actually isn't connected. And so in some settings, high-rise is actually clearly the more efficient approach from an energy energy perspective. But in a different setting, a smaller scale might actually be approached, but it's better. But it's really important to consider context.
And Jonah, did you have any thoughts?
I just one quick thing, not to be self-promoting, but we did a project for the U.S. Green Building Council to do a dynamic LEED plaque that actually tried to factor in. They're running. Somebody's nodding. That's good. So they're running in 20 buildings right now, and the idea is to take dynamic data around transportation, water usage, quality of sort of experience inside the building. One other thing that's not escaping me at the moment, but and rather than have a static plaque bolted to the walls, platinum building, it was a platinum building when you built it, but God only knows, right? To factor in all of these other things and to have a rating, because the other thing is that everybody gets in and cranks up the air conditioning to polar levels, and the energy efficiency of the building goes down, right? So to make that data available and digestible in real time, and specific to that building is I think a nice kind of nod to answer the question that you've raised.
Thank you.
Another question?
Yeah, hi. Gil Friend from City of Palo Alto. I'm really struck by Larry's observations about embedded carbon and the challenge of carbon return on investment. So I want to ask a very specific question to you and a more general version to the rest of you. I'm running experiments in a laboratory called the City a few miles from here that is more or less on board with these concepts. We're building a new sustainability and climate action plan now. We're actually going into a new green building ordinance process starting next month. So the question for Larry is, how do we get at moving the existing building stock ahead of the schedule that owners might have in mind to do sensible retrofits, high carbon ROI, but now, not 5, 10, 20 years from now when they might otherwise normally get to it. We're very good at intervening in new buildings. We don't know how to intervene in existing building stock. So I'd love your recommendations on that. And for the rest of you, what would be the one or two most important, most high leverage things that a city could do to advance what we've been talking about here today?
And then we are...
And this is not an abstract question. This is on the ground right now.
And we are a little bit short on time here, so actually, if you could ask your question to the panel afterwards, we've only got about 2 minutes, so if we could just have the panel answer that question, and then hopefully we'll be able to get to your question when we're all at the break.
Well, Gil's asked me this question before, and the problem is...
And I'm going to keep asking it, Larry.
It's a policy-level question, and it's a tough one, because you have the building code. You can when a new building's built, you can work with the building code and energy codes and things like that. It doesn't happen when you sell a building. Although remodeling, you could tie it again to the code. Yeah. New York, I just heard, was actually looking at implementing mandatory energy upgrades every 10 years to existing buildings, not just new buildings. So they're starting to move into regulating existing building stock, which is really what we have to focus on. It's where all the problem is, really. It's in our existing buildings. And I don't know if, part of it's probably incentives. Part of it's probably giving people, expedited permitting, whatever, if they're remodeling instead of building new. Or I'm into penalizing people for building new big houses that they don't need. If they've got an existing building and they're going to tear it down, remodel it instead and add on. I mean, it's just we've got to somehow change this idea that we all need some new shiny new building, because it's a huge impact. And I don't have. You're better at policy than I am, Gil. So I don't know if you can't come up with it. I don't know if I can. Anybody else?
Well, I would just say, so I'm super optimistic about the work that cities are doing in climate generally, and I feel like, in the lead up to hopefully an international treaty in Paris in December, I'm super hopeful about what's happening at a city level and at a corporate level that's going to hopefully spur that action. I did just spend some time a week ago with the Center for New Urban Mechanics in Boston, if you're familiar with that. No. But they are basically an innovation lab in the mayor's office that's looking at how do we use technology to radically innovate and transform along the lines of sustainability in Boston. And I feel like there's more of those efforts, like chief resiliency officers and whatnot, that are given license to fail and experiment and innovate. And that's what we need more of, I would say.
That's what Gil.
All right.
And just because I have to, because I work in Palo Alto and the traffic, the economy is doing really well, but traffic is bonkers, right? Like something has to happen more systemically. Caltrain and VTA aren't aren't anywhere near to keeping up with demand, right? We could do an autonomous vehicle pilot, talk to our friends down the street, and maybe start to think about leading the charge on getting rid of some of the traffic that's poses a huge sort of quality of life issue.
Well, we're taking a hard look at mobility as a service. So autonomous vehicles is one part of an ecosystem designed to make it easier and more convenient for people to not have to get into a car and drive. Has to be done as a regional scale strategy.
Of course.
Yeah.
Well,
I have to throw this in just because it ties back to the last panel, which is we have to start measuring other things. We have to measure, New York is now measuring pollination levels. Like, we have to measure those things too. We have to measure the number of birds. We have to measure the number of bees. We have to start measuring things that are actually ecosystem providers that we have absolutely forgotten about. That's my last
All right,
point.
wonderful. Thank you. Thank you to our panelists. Thank you.